In this workshop, you will be bouncing 3 different balls and then sketching graphs and drawing force diagrams. There are no calculations, so no numbers are involved. Your graphs will be sketches only, where you'll be considering the shape of each graph. The force diagrams will show the relative sizes of the forces. The equations involved are shown. You'll have to think about the relationships between the variables. Are they proportional? If so, the graphs will have the same shape. To give you an example, this is the rough shape of a height versus time graph for a bouncing ball. But this is neglecting air resistance, so you're going to have to think about how air resistance would change the shape of that graph. Now, potential energy. It's proportional to height, so the graph will have the same shape. It also depends on mass, so you need to consider the masses of the 3 balls when you sketch their potential energies. This is a typical velocity time graph. Notice that since velocity is a vector, it will be negative some of the time since the ball is changing direction. We usually show downwards as negative. Kinetic energy K is proportional to velocity squared, so you need to think about what that graph would look like. Firstly, any negative parts of the velocity graph would have positive kinetic energy, and K is proportional to velocity squared, so that if the velocity graph is a straight line, the K graph will be a parabola. K also depends on mass, so that has to be taken into account too. If you are sketching momentum, the momentum is proportional to velocity, so the momentum graph will have the same shape as the velocity graph. Momentum is a vector, so that graph will have positive and negative parts like the velocity graph. Again, mass needs to be considered for momentum. The total mechanical energy is the kinetic energy plus the potential energy. If there was no energy being lost, the total would remain constant, so that if potential energy drops, kinetic energy must rise, and vice versa. For you, you're told that air resistance is proportional to the speed squared, so the balls will be losing energy as they move. Also, they may lose more or less energy at each bounce, depending on how elastic they are. You have already drawn free body diagrams in a previous workshop, so you should be able to do that again here.